Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, I'm going to show you how you can use some tools in order to run your suspected malware in your sandbox. Again, do not run this on your forensics workstation. Run this in a sandbox, either a virtual machine or a separate non-networked machine that you've set up for this purpose. All right, disclaimer's over. So the first tool is called strace, and it will trace the system calls that are being used by a particular program. And it's very easy to run. So I can just run strace on Xingxi bind shell, for example, and there's my output. It ran a few things and it exited. So let me back up here for a second and see what it ran. First, it ran an exec VE, then it ran access on a couple of things. It opened a file. It did a file stat command, a memory map, and a close. So all of this is related to this shared library. The shared library is loaded. Here we have some more of the same kind of thing going on. Memory map functions are being called, memory protect functions, and some unmapping. Here we're writing out to a file, creating a pipe, cloning a process, reading, and we're reading Python 276. So this is running a Python script which calls clone again, and then it exits. So we can see the kinds of things that are being run. So let's try this on a different program. Now let's run this on Xingxi root shell. Let's see what happens here. Here I have some similar things that are going on. I see an exec VE memory mapping. Files are being opened, closed, some more memory mapping going on. This is all setup information. And then at the end, what do I see? Write to file 1, which is standard out, a new line, then write wrong password. So I'm going to print out wrong password and exit. So why did that happen? That happened because this particular program requires a password that is passed in on the command line. Now, if you look at this in a debugger, as we will do later, you can see all those details. Even just looking at the obj dump, you should be able to tell who is parsing command line argument. So how can we fix this? Well, from our earlier investigations, we know that the password is SW0RDM4N. Let's see what happens if we rerun this with a command line option. And now we get a lot more happening. So let's go back. We have similar things. Exec VE. We open some files. We read in some information, do some memory mapping, and then we duplicate some processes. We register some actions, clone process, and we call wait. So now we had a totally different execution because in this case, we used a command line argument. We can try something similar with the reverse shell. And here we see a printout that says the usage is reverse shell and then an IP. So we did not correctly call it. Again, we could fix that. We could say, okay, how about localhost? And it didn't like that one either. So let's try it with an explicit address. And that time it was happy. So again, we can trace through this. We see our standard exec VE, some calls to open some shared libraries, some memory mapping, a clone, and we exit. So we see just a couple of system calls in this case. In this case, it's not terribly insightful, as to what's going on here. But now, if we do a PS, the question is, does it show all these processes? And it sure does. So you can see they're still running. You can also see that strace is still running. So why is strace still running? It's still running because these processes have not exited. So if I kill 2862, it tells me that 2865 is detached. So that is strace. Now, how does strace work? All it does is run the program you gave it with the command line arguments you gave it, and it prints out any system calls that are made along the way. Now, you saw in a couple of cases that the system calls were not very insightful. That is because of how the program was written. Some programs will use system calls extensively. Others might spawn a new process and do some things in a more direct manner, and you're not going to get as much information that way. But you're going to get something. So it's a little bit better than static analysis, but again, be careful. You are actually running this program, so it will actually install malware, etc. if it is, in fact, a bad program. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.